Hi everyone, and welcome back. So today we're going to look at Unit 2.4, Simplifying Algebraic Expressions, page 299 in the textbook. Go ahead and put today's date for me up at the top. All right, this lesson's just a little bit different. It's very vocabulary based, so you might want to make sure you have your vocab words and stuff like that kind of handy maybe. That might help you out a little bit. Otherwise, we're just going to kind of take it slow here at the beginning, and then once you kind of get the hang of it, we'll pick up the pace. All right. The objectives for today, we're going to identify parts of an algebraic expression. Identify parts of an algebraic expression. Okay. Then what we're going to do is we're going to use the distributive property, which is what we learned in the last lesson, to simplify algebraic expressions. So use the distributive property to simplify algebraic expressions. All right. Let's go ahead and take a look. So I don't want to say this is going to be time consuming because I don't think it's going to be a long lesson, but it's just really different, okay? We're going to be just literally identifying and listing things out. Okay, so the first one says, identify the like terms in the following expressions. So hopefully you've studied your vocab a little bit already for this lesson, or grab the book real quick and open up to it and take a look at what a like term is. So a like term is when you have like the same letter in common, or if there's no letters in common, then it's like the constants are like a 2 and a 5, or a 6 and a 7, or a -1 and a 4. Okay, as long as there's no letters the same, you can put them together. All right. Or if they have the same letters, so they're kind of like the same last names as I like to think of them, like families, then you're putting the families all together, is how I like to think of it. Okay, so let's take a look at letter A. We have 3x plus 4y plus 4x. So which family or which ones does it look like would go together? In this case, it would be the 3x and the 4x. So we have 3x and 4x because we could put those together to make 7x. So that's what they want to know, is what could I put together if I wanted to? All right, let's take a look at letter B. So we have a 5x plus 3 plus 7x and a plus 4. Well, I could put the 5x and the 7x together to make 12x, so that's 1. So 5x and 7x. Okay. Is there anything else that I could put together separately, though? The answer is yes. I could put my 3 together with my 4. So then we say 3 and 4. So again, it's what could I add and subtract together? Okay, multiplying, you can multiply anything together, okay, but what can I add and subtract together is really what they're asking for. And that's one thing that a lot of people forget to mention, is what could be added or subtracted together and put together if we wanted to. Again, I like to think of it as families. So like this is the X family and the Y family in letter A. And this is the X family, and then I call them the orphans. They don't have a last name, all right? They don't know who their family is, so they're just kind of on their own, okay? All right, let's go ahead and try the guided question by ourselves. And let's take a look at it. So we have -4x plus 2y plus 3y plus 2x. So what are the like terms? Well, I have a -4x and I have a 2x. Okay, it doesn't matter that one's negative, one's positive. They have an x in common. That's what we're looking for. Are they in the same family, or do they have the same variable? Okay, same letter. All right, so they do. So this case will be -4x and 2x. Whoops. And then we'll have, we have 2y, which also goes with the 3y. So that's also a little family in itself. Okay, and that's it. All right, now we're going to get into a little bit more difficult stuff. It's not too bad, though. We're just going to take our time with it. We need to identify the terms, the like terms, the coefficients, and constants in the expression 6x minus 2y plus x minus 5. Okay? Well, first of all, what is a term? Okay? A term is each part. Okay? And it's separated by plus or minus. Okay, so which ones are separated by plus and minus? So that would be 6x, and then we're going to use a comma. It's a negative 2y. I know it says minus, but you keep the sign with it, so it's negative 2y. And then we have a positive x, and then we have a negative 5. Okay, if you remember from the previous lesson, I said try to start thinking of them as terms or whole things, okay, not plus and minus so much as actual values, okay, and that's because this is where we need it. Okay, now we're going to do the like terms. So we just covered what like terms are, so I'm not going to write the definition of that up there at the top. Okay, so the like terms, if I could put things together, it would be the 6x and the x. All right, I cannot put 2y or negative 2y technically with anything else, and I can't put the minus 5 or the negative 5 with anything else. They are all by themselves. They don't have anybody else in their family. Okay, next is coefficients. Coefficients, and I use that word a lot as we'll go through in this part of the unit. So the coefficient is the number in front of the variable. Okay, and of course the variable means the letter. Okay, we'll use our actual math words here. We'll say variable, not letter. Okay, so the number in front of the variable. So what numbers are in front of the variables? Well, we have a 6. We have a negative 2. We have, when x is by itself, remember that means 1x. That's where everyone misses the most. Okay, and then that's going to be it. So it's 6 and negative 2 and 1. All right. Constants, you've heard me talk about these before. These are numbers by themselves, so without letters. I guess I should say variables. Okay, numbers without variables. So were there any numbers all by themselves? And it was yes, there was a negative 5. That's it. All right, so let me explain these again. So the terms is each part, and they're separated by plus or minus. The like terms is when they have the same letters in common or they have no letters in common. And then coefficients are the ones where you have the numbers in front of the variables. And then the constants are the numbers without a variable. All right, go ahead and try 2 on your own, okay, on the guided question. All right, let's take a look here. So for this one, we have 3n plus 5m minus 6m plus 2. Okay, so the terms for this one would be 3n, 5m, negative 6m, and 2. Okay, I'll leave the and off. I know you should put an and there, but we're just going to leave it off. We're just going to do a list. Okay, what are the like terms? Well, 3n is all by itself. There's not another one with n, so we can't put that one. 5m also goes with the negative 6m, so those do work. So 5m and negative 6m. And then 2 is by itself, so we can't do anything with that. All right, what are the coefficients? Those are the numbers in front of the variables. So we have 3, 5, and negative 6. Okay, what are the constants? Anything that doesn't have a letter with it, that would be just 2. All right, let's go ahead and move on to the next part. Okay, now we're going to start simplifying these. So we're going to be putting like terms together. Okay, so for this one we have 4x plus 6 plus 2x. So which ones match? Well, my 4x matches my 2x. So we're going to do 4x plus 2x. That's going to make 6x. And then 6 is by itself, so it still has to stay by itself. So I always kind of like to think of a family reunion. Okay, when you go to a family reunion, you're all related, but you all have different last names too. Okay, so like when I go to, well, my dad's side always seems to be the one that has a reunion. So when we go to the reunion, it's actually the Trillion reunion, even though I'm a Marine, but it's because my grandma was the Trillion. So my last name's different than my cousin's, but we're all still family. Okay, I kind of think of it that way. So when it's time to go home, you all have to go back together, right? Okay, so let's look at 6b. So, or I'm not sorry, 6b, 3b. Sorry, we have 5n plus 2 minus n minus 6. So we have a 5n with a minus n. So 5 minus 1. Remember, this is actually minus 1n here. So 5 minus 1 would be 4n. And then we have 2 and negative 6. Okay, so what is 2 and negative 6? Well, we have different signs to subtract. So 6 minus 2 would be 4. Sign of the large number was negative, so that would be minus 4. So it's 4n minus 4. All right, letter C, so we have 6y minus 3 times the quantity x minus 2y. So this is where that other component comes in. We have to distribute first. So we're going to take 6y. Now, what I'm going to do is I'm going to circle this. Okay, I want to distribute the minus 3. Okay, we're going to do a minus 3, not just 3. We're going to do a minus 3. So that way it saves us a little bit of time. So we're going to call it negative 3 now since it's actually a value. So we're going to call it negative 3 times x, which is negative 3x. Negative 3 times, and we're going to circle this, negative 2y. So a double negative makes a positive. And then 3 times 2 would be 6. So it would be 6y. All right, now we're ready to put things together. So I have a 6y, which matches a 6y. And then I have just a negative 3x, so minus 3x. Okay? And I should probably actually switch those around since that's how we usually do it. We usually go in alphabetical order, so it would be negative 3x plus 6y. Oh, sorry, it should be 12y. What am I doing? Back up. Here, let me just redo the whole thing. Sorry. Let me just do it right the first time. So it should have been minus, or negative 3x plus 12y. There we go. Sorry. All right, let's take a look at the got it question. Go ahead and try these by yourself first. And let's take a look. So we have 4x plus 6 minus 3x. So we have a 4x and a negative 3x. So 4 minus 3 would be 1. So that's just x. And then we have plus 6. Remember, we don't write 1x. Okay, x by itself means 1x. Okay, so 3b is 2m plus 3 minus 7m minus 4. We have a 2, and then we have a negative 7. So 2 and negative 7. That's going to make negative 5m. And then I have 3 and negative 4. So 3 and negative 4 would be negative 1. So it should be negative 5m minus 1. All right, so we have 3c, which is going to be, we're going to distribute here, so it's going to be 4q. And then we have 4 times 8, so that's 32. P. And then we have a plus P here on the end. All right, so let's make sure we go in alphabetical order this time. So element O P. So P goes first. All right, so we have 32 and one more, so that makes 33P. And then plus 4Q. Oops. I don't know why it does that. I grab just in one little spot in particular and the whole thing moves. All right. Let's take a look at example 4. So we're almost done. We have financial literacy. It says you have some money in a savings account. Your sister has $25 more than you have in her account. Write an expression in simplest form that represents the total amount of money in both accounts. All right. So we don't know how much money you have. Okay. We just know you have some money. So that's going to be M. All right. We need total. So what are we doing? We're adding. Now your sister has $25 more than what you have. Well, how much do you have? We don't know. We have M amount. So if we have M and our sister has 25 more than us, then that means she has M plus 25. Okay, so this is you, and this is your sister. All right, so how much total would it be? Well, I have an M plus an M, so that's going to be 2M, and then we have plus 25. So all together in both accounts, we would have 2M plus 25. All right, go ahead and try 4A, at least by yourself here, unless you're really not sure yet, and then we'll try 4B on our own, but at least do one of them by yourself and then check in with me, okay? All right, let's take a look. So it says Motto and Lola both collect stamps. Lola has 16 more stamps in her collection than Motto. Write an expression in simplest form that represents the total number of stamps in both collections. All right. So do we know how many Motto has? No, we just know he has some stamps, right? So he'll be S. So he stamps, and Lola has 16 more than him. So that'll be plus, and then his stamps plus 16. So when you put those together, you're going to get 2S plus 16. All right, now let's take a look at 4B. So if you didn't do 4A by yourself, go ahead and pause it and try 4B. Okay, let's take a look. So it says Derek has as many stamps as Motto. Write an expression to represent the total of all three collections. Okay, so we said that Motto had S. Derek has the same amount, so he'll be S as well. And then we have, was it Sarah? No, Lola. Where I get Sarah from, but Lola, she has S plus 16. Okay, so how many do we have all together now? Well, how many S's do we have? 1, 2, 3. So there's 3 S's, and then there's 16. So it's 3S plus 16. All right. So if you need to show this is Motto here. This one's Lola. And down here, this was Motto, Derek, and Lola. Okay? So if you need to show that at the bottom, go ahead and show that. Sometimes it helps to kind of label who's got what. All right, that is it for this one. So go back and look over those like terms and coefficients and constants and all that stuff again if you need to. Otherwise, that's it. Thanks so much for watching. If you can give me a like, that would be awesome. And subscribe. Thanks. Bye.